sets. So with sets of numbers, we start with the natural numbers, or also known as counting numbers. In other words, when we count, what do we count? What do we start with? 1, right? 1, 2, 3, and go on from there. So natural numbers are counting numbers. They're the numbers you count with, so you start with 1. Whole numbers are counting numbers, but they have a 0 with it. N is not symbolized. Natural numbers are symbolized with an N. Whole numbers are symbolized with a W. Integers, those are symbolized with a Z. Integers are positive and negative whole numbers. Okay, so each one of these builds on the one before it. Rational numbers is symbolized by the letter Q, probably for quotient, because rational numbers are like fractions. Okay, basically an integer over an integer. Rational numbers are fractions, and there also can be decimals that either terminate or end, like in 1/2 is 0.5, right? Or 1/3 is like 0.3 repeating, right? Or 2/3, 0.6 repeating. So those are rational numbers, okay? So you can have 2 is considered a rational number because 2 over 1 is still 2, right? But it can be like a fraction, right? So rational numbers could also be integers or whole numbers or natural numbers. Irrational numbers, they're symbolized with the letter H. Usually N, W, Z, R is usually the biggest one we use for symbol. Not so much A or Q. Irrational numbers are basically they are decimals that do not end or terminate, or they do not repeat. In other words, radical numbers like square root of 2 is irrational. It doesn't have a pattern to it. Or pi is irrational, 3.14159, it goes on and on and on. We usually just think of 3.14, but pi goes on forever. E is another one, 2.71, and that goes 2, and that goes on. So the most common one, though, is the radical. The radical that does not simplify to a whole or a natural number, or not an integer, because you can't have negative inside the radical. Okay, even radical. So irrational numbers, no pattern to them. Okay, real numbers are all of these. The only thing real numbers do not, the only thing that real numbers do not include are imaginary numbers, such as I, right? Imaginary or complex numbers. So, all right. Any questions with that? Yeah, you know, actually there's only supposed to be 15 in the class, so let me see if there's another chair back here. We have to stay 6 feet apart, so okay. Any questions with that so far? Okay. I don't know. All right. A set. A set is a collection of objects. Commonly used, we use brackets for a set. They don't have brackets in them, it's not a set. So you have to include the curly brackets in them. Okay, so this would be considered set S, and the elements in set S are 1, 2, 3, 4. This would be considered set N, 1, 2, 3, 4. And these dots on the end mean they go on forever. So the S is the name of the set. Okay. Here the N is a natural number. So natural numbers are, remember, counting numbers. Those have dots on the end because counting numbers go on forever. So when you see the dots on the end like that, that means it continues on. There's no end to it. Okay? All right. Here, you have this curly bracket and then X. That X is the set of all, that X means the set of all elements in set X. The bar, or sometimes it's like a colon, 2 dots, means such that. So this is the set and the elements of set X such that X is the natural numbers between 2 and 7. So natural numbers being counting numbers between 2 and 7, that would be what? Between 2 and 7 would be 3, 4, 5, 6, right? Good. Questions there? Okay. Braces or brackets are used to group members in the set. So the numbers here, oops, back up. These are elements, okay, inside. They're the elements within the set. The brackets it symbolizes the set. They group the elements in the set. Empty set or null set is either symbolized by empty brackets or this 0 with a line slash through it. Anybody here prior military? No? Okay. I'm retired Navy, by the way. The military uses their zeros or a 0 with a line through it, but sometimes they give veterans in my classes and they look at that and they kind of get confused. But in math, that's considered an empty set. Okay? All right. So this E looking symbol, that means the element in that set. So if we were to look at this set here, 1, 2, 3, 4, we could say that 2 is an element in 1, 2, 3, 4. So like this. So let me do this. So we could say 2 is an element in set 1, 2, 3, 4. Okay? So it just signifies this item here is a part of that set. All right? Okay. Okay, so this E looking symbol with a line through it means it is not an element of that set. So we could say something like this. We could say A is not an element of 1, 2, 3, 4. Okay? Okay. Questions? Alrighty. This C looking symbol, that means a subset of. In other words, you could say that anything, you could, back up. You could say that in our set 1, 2, 3, 4, we could say that 2 and 3 is a subset of 1, 2, 3, 4. Okay? So everything that's in the first set has to be in the second set. So in other words, if I had a 0 here, I could not say that this is a subset because all the elements of this first set have to be in the second set in order for it to be a subset. Okay, if there's one element that is not, then it's not a subset. Okay, questions there? Okay, so sometimes you'll see it, a C-looking symbol with a line underneath it. That just means subset or equal to. Alrighty, an infinite set. Put two. Remember in the syllabus I told you where to put stars? Well, every once in a while I'll tell you to put a star somewhere in your notes. This is one of those. Don't put one star, put 2 stars, because you're going to see this more than once. Infinite set. One that has an unending, in other words, it goes on forever. Infinite. So when the dots are on the end, that means infinite set. When the dots are in the middle, that means the sequence continues. In other words, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So this means finite. Well, why do we do that? Well, if we had something like this, if we had 2, 4, 6, 8, so it's developing a pattern, right? Dot, 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 100. So you can see the elements in the set, but you don't have to write everything. And so it has a beginning and it has an end. And it has dots in the middle. So with dots in the middle, this is a finite set. When the dots are on the end, 2, 4, 6, 8, dot, dot, dot. When the dots are on the end, infinite, right. Put stars, 2 stars on both of those, both of them. Okay? Questions there? All right. Now, you'll see fractions that have a beginning and an end. If it's fractions, with fractions, it could have dots on the beginning or the end, or in the middle or in the end, and they're still infinite because you could have from 1 to 2, there's an infinite number of fractions, right? 1/2, 1/3, 1/100th, 1/1000th, 1/1,000,000th, right? Infinite number of fractions. So it doesn't matter, for fractions, it doesn't matter if the dots are in the middle and the end, those are going to be infinite. But for integers or whole numbers or rational numbers, that's what we do. Now the fractions are not going to be on the test or the quiz, all right? Because to me, I just think that we just need to get this part down first. Okay, example. So this is where you're going to write in your notes. I didn't put the answers down there yet. List the natural numbers less than 6. So natural numbers, what are they? Counting numbers, right? So natural numbers are counting numbers. So natural numbers, counting numbers less than 6. What would that be? 1, 2, 3, 4, 5. Good. Okay. Let me go do this. That way you can see the answers as we do it. Come on. Okay. True or false? Identify each of the following statements as true or false. Natural numbers, right, n, is a subset of whole numbers. Is that true or false? False. Natural numbers. Let's go back. Way back here. Natural numbers. 1, 2, 3, right? So on goes on. Whole numbers. 0, 1, 2, 3. So can we say natural numbers are a subset of whole numbers? Yeah. Everything that's a natural number is a whole number, right? So we can say that natural numbers, right? And I like to use a little fancy in there. Natural numbers is a subset of whole numbers. Okay, 1, 2, 3, 0, 1, 2, 3. So this is true. This is 1, 2. That's true. But can we say, now they didn't ask this on the PowerPoint, but I'm asking it. Can we say that whole numbers is a subset of the natural numbers? That is false. That is correct. That is false, because you have 0, 1, 2. Here we have 1, 2, 3. So 0 is not part of the natural numbers. So we don't have everything in this first part that's in the second. So everything in the first set has to be in the second in order for it to be a subset. Okay. All right. Questions with that? All right. Back up there. Okay, we good? First, yeah. The first set is always the subset. All right. Everything in the first set has to be in the second set in order for it to be a subset. If it's not, then it's not a subset. Okay. Okay. Good. So, second question, 2.2, 2.3, 2.4. Can we say that this set is a subset of the whole numbers? That is correct. We don't have decimals in the whole number set. Okay, very good. Questions with that? Questions? No questions. All righty, good. So are these notes helping?
Yeah.
Okay, good. All righty. Example 1, use the set notation terminology. Identify finite or infinite. Okay. First one is finite. Good. Second one? Infinite, right? Even though it's fractions, it's still on the end, so it's okay. So I still kept that one in there. So that one is infinite. X, all elements in set X such that X is a fraction between 1 and 2. Fractions, remember, fractions. Anytime we have fractions, they are what kind of set? Infinite or finite? Fractions are always infinite. Yeah, always. Okay, always, because you can have infinite fractions in between two whole numbers. Okay, X, all elements in set X such that X is a natural number between 9 and 11. Natural number, what kind of numbers are those? Counting, right? So natural numbers are counting numbers. Can we have counting numbers between 9 and 11? Yeah, we sure can. So is that finite or infinite? Finite. Good. Questions? All right, it's got a beginning and an end. So we could also say that the dots are in the middle on that one, right? Okay. Let me put this back on. Okay. Use set notation. X is an element, all elements in set X such that X is a natural number less than 5. Okay, so we want to use set notation to list the elements. Natural numbers. What kind of numbers are they? Counting numbers. Good. Counting numbers less than 5. So that would be 1, 2, 3, 4. Yeah, 1, 2, 3, 4. Good. all elements in set X such that X is a natural number greater than 7 unless than 14. Natural numbers. 8, 9, 10, 11, 12, 13. Good. Questions? All right, you guys got this. Okay, Venn diagrams. We don't get into Venn diagrams on the homework too much, but they're good to help understand sets, so we still use them. Okay, so Venn diagram depicts a set. Okay, you can picture set A, points inside the circle. All right, the universal set are all elements that we are considering or looking at. All elements that contain every object that we are interested in looking at. The complement, with a little mark on it, is the set of objects in the universal set that are not in set A. Okay, so here we have the universal set. Numbers from 0 to 10. Natural numbers from 0, or no, whole numbers from 0 to 10. Okay. Set A has 1, 3, 5. So the complement would be everything that is in the universal set that is not in set A. Well, let's look at this another way. Okay. All right. Here's our universal set. Universal set 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and we have set A. We said that was what? 1, 3, 5? I'm trying to remember now. Set A. Where are we? Where is this? Oh, here we are. Okay, 1, 3, 5, 7. Am I right? Okay. Now the complement is going to be everything in the universal set that's not in set A. So what we do is we look at set A and we start crossing out. So here's 1, can't cross out a 1. 3, cross that out. 5, cross that out. 7, cross that out. Anything that's not crossed out that was in set A is in the complement of set A. So that would be 0, right? What else? 2, 4, 6, 8, 9, 10. Good. Put a star on that one. You will see that again. Questions? Actually, put 2 stars on that one. You'll see that one more than once. 2 stars, yeah. 2 stars. Alrighty. We did all that. Okay, so let's look at some problems. Here's our universal set. 1, 2, 3, 4, 5, 6, 7. So set A is 1, 3, 5, 7. So pretty close to what we just did, right? So what would be the complement of set A? So cross the 1 out, right? So it'd be 2. Cross 3 out would be 4. 6. Yeah, so 2, 4, 6, right? All right, good. Here's B. 3, 4, 6. Here's our universal set. So the complement to set B, so that would be 1, 2, 5, and 7. Good. Questions there. Good, you got it. Okay, so the complement of the empty set, complement of no set, nothing, is everything, right? So the complement of the empty set would be the universal set. Okay, complement of the empty set is the universal set. Okay, complement of nothing is everything. Complement of everything is nothing. So that would be what? Empty set, yeah. Okay? Good. Questions? So you could have also used it in empty brackets there too. All right. Okay, so here, A is a subset or equal to, in other words, it's got at least everything in it, or some, it could actually, we don't know, it's like less than or equal to, so it's subset or equal to, same thing. So set A is a subset of set B if every element in set A is also an element of set B. All right. The first set is always a subset. Okay, so 259 is A is a subset of set B. All right. So on the Venn diagram, this is what a subset looks like. Everything in set A is also in B. But everything in B is not in A. So B, right, B could not be a subset of set A, right? Because there's elements in B that are not in A. So they would not be equivalent. Two sets, A and B, are equal if A is a subset of B and B is a subset of A. If two sets A and B are equal, we write they're equal. Okay, so what would be an example of that? If we had natural numbers, right, are a subset of the set 1, 2, 3, 4, ... right? Well, natural numbers is a subset of 1, 2, 3, 4, and 1, 2, 3, 4, ... is a subset or equal to natural numbers. So when they're the same, right, basically when they're the same set, maybe they're named differently, then we can say that the natural numbers are equal to 1, 2, 3, 4, ... Okay? So that's an example of that. All right? Questions? All righty, moving right along. Okay, example 3. Let the universal set 1, 3, 5, 7, 9, 11, 13 and set A 1, 3, 5, 7, 9, 11. Okay, B is 1, 3, 7, 9. C is 3, 9, 11. D is 1 and 9. Can we say that set D is a subset or equal to set B? Is D, everything in D in B? Well, D has 1 and 9, right? So is 1 and 9 in set B? Yeah. Yeah. So can we say set D is a subset of B? Yeah. Yeah, we can. Good. All right. But is B a subset of set B? It is not, because D does not have 3 and 7 in it. So that would be false. Very good. Now this means not a subset. So can we say C is not a subset of set A? So in other words, there's something in C that's not an A. Let's see. 3, 9, 11. So actually C is is a subset of set A, right? So is this a true or false statement? This is false, right? Because this is saying C is not a subset, but it is a subset. So it's false. Good. And then universal set is the same as set A. So is that a universal set equivalent to set A? So in other words, not everything. Yeah, because 13 is not in set A, right? So you got to be careful with that. But we could say A is a subset of the universal set, right? But they're not equivalent. So that's false. Good. Questions with that? Alrighty. Given two sets A and B, sets of all elements belonging to both sets A and B is the intersection. So given set A and B, the set of all elements belonging in both. So whatever's common in both sets, that's the intersection. Okay? So we could say that the intersection of, well, no, that's not a good example. Oh, here we go. For example, set A, 1, 2, 4, 5, 7, and set B is 2, 4, 5, 7, 9, 11. So the intersection for these two would be 2, 4, 5, and 7, because they're in both sets. So the intersection means that the elements are in both. Okay. So this upside down looking U symbol, that means intersection. So all elements in set X such that elements in A and B in both. So 2, 4, 5, 7, 1, 2, 4, 5, 7, or 2, 4, 5, and 7 are in both. 2, 4, 5, and 7. Okay. So two sets that have no elements in common are known as disjoint. Disjoint. Okay. Like if you ever play sports, football maybe, and you get shoulder, out of joint, disjoint. So kind of the same thing. Okay. All right. So the intersection of A and B, 2, 4, 5, and 7. Okay, 2, 4, 5, and 7. 1 is not, because 1's not in both. 9 is not, because 9's not in both. 11 is not. Okay, so it's symbolized by the shading of the region that is common to both. All right, in the Venn diagram. Okay. Find each of the following. Identify any disjoint sets. Alrighty. Problem A. So, intersection, right? Is 9? No, it's not. 15. Yeah, 15's in both, so we can put 15 here. What about 20? 20 is not. What about 25? Yeah, 25 is. We can put 25 down. What about 36? No. 30? 35? No. Just 15 and 25, right? Okay. How about the next one? 2, 3, 4, 5, 6 intersect with 1, 2, 3, 4.
You do 2, 3, 4.
2, 3, 4. And that's all, right? Not 5, not 6, not 1. Okay? Questions? All right, go ahead and do the last one on your own. Yeah, nothing. So that's called what? Disjoint or empty set, right? Empty set or disjoint sets. Okay?
So like say if we have a test, so right?
What?
I said, say if you have tests on it, we just gonna put R.1 Sets right there. Like,
Yeah, it's multiple choice. It'll say disjoint on it. Any other questions? Alrighty. The union includes everything in both sets, but you don't repeat it. The union of two sets, A and B, is a set containing those elements which are in elements A or B. So in other words, everything. You include everything in both. So union is a U-looking symbol. Okay? So the union would be 1, 3, 5, 7, 9. We include everything, but we don't repeat it. Okay? So that's different than intersection, right? Okay, questions? Okay, so with the union, we color in everything. Everything's colored in. All right. Okay, find the unions. Okay, so we got 1, 2, 5, 9, 14. 1, 3, 4, 8. So 1, 2, 3, 4, 5, 8, 9, 14. Good. Questions there. Everything. How about the next one? 1, 2, 4, 5, 6, 7. Yep, straight on. Well, union. For an empty set and 2, 4, 6, it's just 2, 4, 6. Yeah. Questions there? Okay.